Hello, in this video we're going to discuss monetary policy, and we're going to be using the real Taylor or RT curve to help us understand how monetary policy is set in a modern economy. The first thing that we want to note is that central banks have objectives. For example, in the United States, the Federal Reserve, which is the U.S.'s central bank, has a dual mandate to keep prices stable and also to maintain full employment. In fact, that's the way it is in most other countries. The central banks have a mandate of a similar nature. They need to keep prices stable, but they also need to keep output stable. To reach these objectives, central banks must implement monetary policies. In most cases, the central bank sets a short-term interest rate. We often call this the policy interest rate, or the interest rate at which banks borrow from one another. For example, in the United States, that rate is called the federal funds rate. To be more effective, central banks must also communicate clearly with the policy. They have to issue periodic statements, and they also have to help the public understand what policies will likely be taken and why. Central bank policies, it turns out, can follow a kind of predictable pattern, and we call these patterns monetary policy rules. Monetary policies can help us understand how central banks set interest rates in their aim to meet their objectives. Policymakers themselves sometimes use monetary policy rules to help them formulate policy. The rule helps tell them what interest rate they should set. The Taylor rule has become a very widely used framework for understanding how monetary policy is set. There was an important 1993 article by Professor John Taylor of Stanford University who found that central banks behaved in a way that was kind of predictable. There was a pattern. The pattern was broadly consistent with the central bank's dual objective of keeping the prices and output level stable. And this predictable pattern has come to be known as a Taylor rule. The original Taylor rule told us about how the central bank sets the nominal interest rate. However, it's the real interest rate, not the nominal interest rates, that affects economic behavior. Just to refresh your memory, the real interest rate is approximately equal to the nominal interest rate minus the inflation rate. So if the nominal interest rate is 5%, but the inflation rate is 3%, the real interest rate is about 2%. So we're going to be extending the original Taylor rule to examine how the central bank sets the real interest rate. That's the rate that affects economic behavior. And we're going to be calling this rule the RT, or real Taylor curve. Now, there's an important point here. During normal times, the nominal interest rate that the central bank sets is typically above zero. However, during deep economic downturns, or when prices go down, negative inflation, deflation, the rule might tell us that the central bank should set a negative interest rate. Well, for now, we're going to be ignoring those cases. We're going to say that the zero lower bound does not constrain. If you want to know more about the zero lower bound, you might want to look at chapters 11 and 12 in the book. So we're going to build up to the real Taylor rule. We're going to start from a point of reference, what we call a baseline scenario. The output level is at its potential, which means that the output gap exactly equals zero. The inflation rate must be equal to the desired or target rate of inflation. So if the central bank says they want the inflation rate to be 2%, that's what the inflation rate we're going to assume actually is. Also, we're going to assume here that the central bank enjoys full credibility. People expect the inflation rate to be exactly the target rate set by the central bank. Under this baseline scenario, the central bank is going to align the nominal interest rate with the long run, or what we call the natural real rate of interest, plus the inflation rate. And here's the equation, that the nominal rate of interest is going to be equal to the real rate of interest plus the inflation rate. This is the Taylor rule under the baseline scenario. If we take this in real terms, we can see, just subtracting inflation from the left-hand side and the right-hand side, that the real interest rate is going to be equal to the natural rate. Now, what is the natural rate? The natural rate is determined by certain long-run economic fundamentals, including how productive capital is and how durable it is. So it turns out that the more productive capital is, the higher its marginal product of capital, the higher the natural rate of interest, and also the more durable capital is, the less depreciation there is, we're also going to have a higher natural rate of interest. Under our baseline scenario, we're going to be at point A. The output gap is equal to 0, and the real interest rate is equal to its natural level. So our baseline scenario is going to be represented by point A in the graph below. The output gap is equal to 0, and the interest rate is at its natural rate. Now let's suppose that the output gap increases. The central bank must raise the interest rate, and we're going to be moving from point A to point B. Now, this is consistent with the central bank's dual mandate. Since demand is increasing, the economy may be overheating, resources are being stretched too much. The inflation rate will begin to rise. The central bank will need to restrain demand by raising the interest rate. Its goal will be to cool the economy down. Alternatively, suppose that the output gap decreases. The central bank must, in this case, reduce interest rates. We move from point A to point C. In this case, reducing interest rates would be consistent with the central bank's dual mandate. The economy is cooling down. Unemployment is rising. There's idle capacity. We want to put people back to work. The inflation rate will begin to fall also. The central bank needs to stimulate demand by reducing the real interest rate. Its goal will be to kickstart the economy. So we move from point A to point C. So points A, B, and C lie on an upward sloping line that summarizes central bank interest rate policy. This is the RT curve. This line tells us that if everything is held constant and the central bank follows its Taylor rule, there will be a positive relationship between output and the real interest rate. In most cases, by sticking to its Taylor rule, the central bank can signal that it is serious about achieving its objectives. Now, there's a couple of things we need to know. First of all, the central bank needs to be keenly aware of the Phillips curve. The Phillips curve, recall, tells us about the relationship between inflation and the output gap and other variables. It tells us, for example, that inflation will rise when aggregate demand increases, if there's a bad or adverse shock to the short-run aggregate supply curve, or inflation expectations rise. And it's symmetric the other way around. So, the central bank needs to know about the output inflation trade-off. It needs to know whether, in effect, the Phillips curve is steep, you have more flexible prices, or whether it's flat and you have stickier prices. And it turns out, if you have a steeper Phillips curve, the central bank will have to give a more vigorous response to changes in aggregate demand. It'll have to raise interest rates even more than otherwise. Alternatively, if it is determined that prices are relatively sticky, that is, we have a flatter Phillips curve, that means a less vigorous response is required in response to a change in aggregate demand. The other thing that the central bank needs to be keenly aware of is why the output gap has changed. Now, you remember that there are three factors. These two factors here, the aggregate demand could increase. If there's a shock to the aggregate supply curve, both of these factors will affect the output gap. But it turns out that the central bank has to respond to them in different ways. To conduct monetary policy, then, the central bank needs to ask, what kind of shock is causing the output gap to move? Is it due to a change in aggregate demand? For example, if we have more government spending, we have higher demand, we're going to have a higher output gap, and we're going to have higher prices. But it turns out that we could also have a shift in the aggregate supply curve, and natural events such as a hurricane, an earthquake, or maybe harvest conditions. So we can have a good shock, a good shift to the short-run aggregate supply, a favorable shock. Okay, for example, we could have a better than average harvest, or we could have lower oil prices. Both of these shocks will cause the output gap to increase, but prices will fall. We're going to see that unlike shocks to aggregate demand, shocks to aggregate supply will cause the RT curve to shift. So for example, let's suppose that we have an adverse or a bad shock to aggregate supply. That means we're going to get a leftward shift of the RT curve. This means the central bank will be tightening even more to restrain the inflationary impact of an adverse or bad supply shock. This is going to help keep inflation expectations in line. So this leftward shift means that we have higher interest rates than otherwise for any value of the gap. Alternatively, let's suppose that we have a favorable or a good shock to short-run aggregate supply. The RT curve in this case is going to shift to the right. In this case, when we have a good shock, for example, an extraordinarily good harvest, the central bank is going to loosen to keep prices from falling too much because it wants to keep close to its inflation target on either side. So in the event of a favorable or a good supply shock, we're going to see lower interest rates for any value of the gap. Now, there are other reasons why the RT curve may shift. One of those reasons is a change in expected inflation. So let's suppose that the market expects more inflation. This means that the central bank has lost credibility on the upside. The central bank needs to send a signal that it's serious, so it's going to tighten, and that means that the RT curve will shift to the left. But notice that this often works in the other direction. For example, if the market expects less inflation, they expect prices to go down. In this case, the central bank wants to signal that just as it's not going to let prices rise too much, it's not going to let prices fall too much. So the central bank needs to loosen, and in this case, the RT curve shifts to the right. Now, it turns out that there are other reasons why the central bank may depart from its initial Taylor rule, and we call this central bank's discretion. There often are times there are things on the horizon that the central bank sees that perhaps the rest of us don't see. So in this case, the central bank may depart from that rule. So if we have a discretionary tightening, the RT curve shifts to the left. If we have a discretionary loosening, the RT curve shifts to the right. So here are our key takeaways from this video. The RT curve tells us about how the central bank formulates monetary policy according to its well-known Taylor rule. We're extending the work of Professor John Taylor of Stanford University. The RT curve is reflected in a positive relationship between the output gap and the real interest rate, as we've been seeing in this video. The RT curve will shift to the left. That is, we'll have even tighter monetary policy in the event of an adverse bad supply shock, an increase in expected inflation, or if the central bank exercises its discretion, oftentimes on the basis of other information that it has about inflation or the output gap in the future. In the other direction, the RT curve will shift to the right. That means even looser policy if we have a favorable, a good supply shock, if we have a decrease in expected inflation, or once again, the central bank may loosen on a discretionary basis because it has some other information. So if you're interested in a deeper treatment of these ideas, including how you might want to put some numbers to them, I highly recommend that you look at chapters 11 and 12 in the book. Okay, that's it.